Hey, this is Mr. A, and we're still in Unit 5, and we're going to put everything together here. We have done the first derivative test, we've done the second derivative test, and now we're going to be able to sketch graphs and their derivatives using the first and second derivative test. So let's get it on. Here we go. Here's an example. We're going to go right to examples because we're ready to apply everything we've learned. We have this function, f of x equals 3x to the fourth minus 4x cubed plus 2. I always like to, I take a look, I plug in 0 real quick, and what do I get? I get 0, 2. That is a nice reference point that I have, and now I can know all kinds of things by doing my first and second derivative test. So let's do a first derivative test. F of x equals 12x to the third minus 12x squared, which means I can factor out a 12x squared, and I get x minus 1, x minus uno, which means I have x is equal to 0 and I have x is equal to 1. Those are my critical points. Remember, first derivative test tells us critical points. Okay, critical points. I'm going to plug in some numbers inside this function. So let's plug a negative number in. If I plug a negative number in, that's going to be squared. That's going to be negative, which means that's going to give me a negative value. I'm going to plug in like 1/2. If I plug in 1/2 in here, I'm going to get 1/2 squared. That's going to be a fraction. I'm going to get still a negative number. If I plug in a number bigger than 1, I'm going to get all positive values, aren't I? Which means x is equal to 0 is not a max or a min, okay? Because it doesn't go from positive to negative or negative to positive. But here, my slopes are negative, and then it's going to go positive again, which means this is going to be a relative min at x is equal to 1. Now, what do I do next? Let's take the second derivative of x. So I'm going to take this function in blue. I'm going to do another derivative. I have 36x squared minus 24x. And what can we factor out? Let's factor out a 12x. And we're left with 3x minus 2, which means we have x is equal to 0, and we have x is equal to 2/3. Now, what does this tell me? This will tell me whether I have inflection points right here. So remember, blue is in critical points. This is telling me, do I have inflection points? But I got to test this using my data. Okay, so let's put in a negative number. If I put a negative number in, I get a negative. I'm going to get a negative, which means I'm going to have negative times a negative is a positive. I plug in a number like 1/2. I get a positive here. I'm going to get a negative here. I get a negative. If I plug in a number like 1, I am going to get positive values when I plug it in this second derivative function, which means here we are concave up, here we are concave down, here we're concave up, which means I have inflection points both at 0. Inflection point. I have inflection point right here. Inflection point at each of these two values. Now I'm going to try to sketch this graph. Okay? When I'm less than 0, I'm concave up. But I don't have a min or a max, which means my graph is going to kind of look probably something like this, because that is going to be concave up. It's not giving me, I don't want to concave up this way because I know my values are decreasing. My slopes are going negative. Again, concave up can look anything like this. Now, one side has slopes decreasing, one has slopes increasing. This has, it's negative, so my slopes are decreasing on this, decreasing on it. Then I begin between 0 and 2/3. About 2/3 is about right here. I start going concave down, but my slopes are still negative. So remember, concave down can be anything here. Which one shows my slopes being negative? This one shows my slopes being positive. This side shows my slopes being negative. So my slopes are going to be negative here. And I'm concave down. And what do I have right here? I have an inflection point at 2/3. And now I'm going concave up with a minimum at 1, which means I go back concave up with a minimum, and we're back concave up. So you can see here I have on my graph, I have slopes that are negative. I got slopes, that's first derivative graph, that are negative. I'm concave up though. From 0 to 2/3. I am going concave down, and my slopes are still negative, aren't they? Then I have an inflection point right here. Then I'm concave up with a minimum right at positive 1, and that should be my graph. Let's take a look. There it looks. There's my graph. I did a great job at sketching. Yeah, I'll pat myself on the back. Pat, pat, pat. Great job, Bobby Yaton. That is a super duper duper job at sketching that graph. We don't have to get the graph perfect, but our first and second derivatives give us information. Okay, let's go to one more example, and this example is going to be x cubed minus 12x plus 2, and let's do my put in 0. So I put in 0, 0x squared minus 12 times 0 plus 2. Oh, what do you know? I got a 0 right at 2 right there. Okay, so that's a nice number I can know. So let's take my first derivative of this function. I get 3x squared minus 12. 3x squared minus 12. And I am going to then plug that into my either my calculator, or I'm going to set that equal to 0. And x could either be plus or minus 2. X could be negative 2 or x could be positive 2. And those are my possible critical points. Those are my critical points. Okay, now let's see if they're maxes or mins. We're going to plug in a number less than negative 2, and I'm going to get a positive value. I'm going to plug in 0, I get a negative value. A number bigger than 2, I'm going to get another positive value, which means I am going from positive slopes to negative slopes, which means I have a max right here at negative 2. I have a min right here at positive 2. And that's what I know from my first derivative. Let's take a look at my second derivative. My second derivative, I get 6x. And that's it. I can equal that to 0, which means x is equal to 0 could be an inflection point, right? It could be. But I'm going to plug in some numbers. Let's plug in a number less than 0, and I get negative values. I just plug it right in. The positive values is going to give me positive, which means this is concave down, less than 0, concave up, greater than 0. Concave down, less than 0, concave up, greater than 0. Okay? A lot of people like to take this negative 2 and this positive 2 and plug it in my original function. If you plug these guys in my original function, it gives you some points. If I plug in f of 2, I get 2 to the third power is 8 minus 24 plus 2. And when I do that, I get negative 14. That's my minimum value. So f of 2 is negative 14. If I plug in negative 2, I get negative 8 plus 24 plus 2. And that is, what is that? Is that 18? Let's see, 24, 26, yep, 26, 18. 18. So f of negative 2 equals 18. So at negative 2, we're at 18. We're all the way up here. F of 2, we're at negative 14, all the way down there. And so I know that this is my max, and I know that this is my min. Okay, those are my relative maxes and mins. Now, what do I know? I know I have an inflection point right here at 0, 2. At f of 0 is equal to 2. I'm concave down, okay, which means my graph is going to be concave down right there. Then I have an inflection point, and I am going to be concave up, okay? And that is a good sketch of my graph. Not beautiful, but good. And let's see if this graph holds up. That is exactly what I see. You can see right here at negative 2, I have my max. At positive 2, I have my min. My slopes are going from negative to positive. My slopes are going from positive to negative. I have an inflection point here at 0, 2, and that showed both my first and second derivatives. And so with our first and second derivative test, we can know so much information about my graph, way more information than I ever knew before. And now you know, and knowing's half the battle. G.I. Joe, dun, dun, dun. That's Unit 5, sketching graphs. See you guys. Bye.